Dear learners, I welcome you all to this online teaching session. Today, in practical number 2, we will discuss about estimation of paracetamol and mefenamic acid in given tablet sample using simultaneous equation method. So, aim is to estimate percentage waste by weight of paracetamol and mefenamic acid in given tablets using simultaneous equation method by UV spectrophotometry. The reagents and chemicals required are standard paracetamol, standard mefenamic acid, tablet containing paracetamol and mefenamic acid, zero point 0.1 normal sodium hydroxide. The role of sodium hydroxide is to dissolve the standards as well as sample and distill water to prepare zero point 0.1 normal sodium hydroxide. Apparatus, you require volumetric flask 50 ml, 100 ml depending upon your requirement. Then 10 ml volumetric flasks, pipettes and beaker and funnel. You require Wattman filter paper for filtration of standard solution as well as sample solution, and tissue paper for wiping of cuvette. Instruments, of course, you require UV visible spectrophotometer and high precision weighing balance is required for weighing purpose. This slide depicts drug profiles, paracetamol and mefenamic acid, structure, molecular formula, molecular mass, melting point, CAS number, IUPAC name and use. To start with, first you have to prepare standard solution of paracetamol. So, weigh 5 milligram of paracetamol and dissolve in 50 ml of 0.1 normal NaOH to prepare 100 ppm of solution containing paracetamol. From this, accurately measure 1 ml of solution and dilute it up to 10 ml with 0.1 normal NaOH to prepare 10 ppm paracetamol solution. Similarly, prepare mefenamic acid solution 10 ppm. So for that, initially you have to prepare 100 ppm solution. So dissolve 5 milligram of mefenamic acid standard in 50 ml of 0.1 normal NaOH. So this will give you 100 ppm solution containing mefenamic acid, and from this solution accurately measure 1 ml of solution, transfer it into 10 ml volumetric flask and dilute it up to 10 ml with again 0.1 normal NaOH to produce 10 ppm of mefenamic acid solution. The sample which we have taken is paracetamol and mefenamic acid tablet. The average weight of this tablet is 930 milligram. To calculate average weight, you have to take 20 tablets. Individually, you have to weigh the tablets and you have to calculate average weight of the tablet. So, this tablet is having average weight 930 milligram, and single tablet contains mefenamic acid 500 mg and paracetamol 325 mg. So, this is the label claim for our sample. Now for sample solution, as we know that our tablet contains 500 milligram mefenamic acid. So 500 milligram mefenamic acid is present in 930 milligram of tablet powder. So this is our average weight. Tablet you have to triturate, you have to make fine powder. So the 930 milligram of tablet powder contains 500 milligram of mefenamic acid. So for 10 milligram mefenamic acid, you require X milligram of tablet powder. So X is equal to 10 into 930 upon 500. So it comes around 8.6 milligram of tablet powder. So you have to take 8.6 milligram of tablet powder, which corresponds to 10 milligram of mefenamic acid. So 8.6 milligram tablet powder you have to take and you have to transfer it into 100 ml volumetric flask, and slowly some volume of NaOH you have to add, sonicate it and make up the volume up to 100 ml to get 100 ppm of mefenamic acid. Now why this solution will be having 100 ppm of mefenamic acid? Because 18.6 milligram tablet powder contains 10 milligram of mefenamic acid. So 10 milligram dissolved in 100 ml, so it will produce 100 ppm of mefenamic acid. Now from above solution, you have to prepare again 10 ppm solution. So this solution, from this solution accurately measure 1 ml of solution. Of course you have to filter before this procedure. So once the 100 you have make up the volume up to 100 ml to prepare 100 ppm solution, filter the solution, and from that accurately measure 1 ml of solution and dilute it up to 10 ml. So you will get 10 ppm of mefenamic acid. Now this is all about the mefenamic acid. Now what about paracetamol? So because this tablet powder contains both mefenamic acid and paracetamol. So this 18.6 milligram tablet powder contains 10 milligram of mefenamic acid. So we must know how much paracetamol we have transferred, because along with mefenamic acid you have paracetamol also as a API in your dosage form in your tablet powder. So 930 milligram of tablet powder, this is our average weight, contains 325 milligram of paracetamol. So 18.6 milligram which we have transferred, it contains how much milligram of paracetamol? So Y is equal to 325 into 18.6 divided by 930. So it comes around 6.5 milligram of paracetamol. And this we have transferred to 100 ml 0.1 normal NaOH. So this comes around 65 ppm of paracetamol. If you calculate very well 6.5 milligram in 100 ml, so per ml 65 microgram, that is 65 ppm paracetamol we have prepared. And the solution was again diluted 10 times. So when we did dilution 10 times, so it is having 6.5 ppm of paracetamol. So now next is, so we have three solutions with us: mefenamic standard solution 10 ppm, paracetamol standard solution 10 ppm, and we have tablet powder containing mefenamic acid 10 ppm and paracetamol 6.5 ppm. So what you have to do? This mefenamic acid you have to scan into UV using 0.1 normal NaOH as a blank, because the solution is prepared in 0.1 normal NaOH. So you have to take 0.1 normal as a blank, and you have to find out lambda max of mefenamic acid. Here we have given X to the symbol X to mefenamic acid and symbol Y to paracetamol. So find out the lambda max of X, that is mefenamic acid, and state it as a lambda 1. So this will be our lambda 1. Measure and simultaneously you record the absorbance, and using that absorbance calculate AX1, and at this after that you scan paracetamol solution in the same way, find out the lambda max, that will be your lambda 2, and again you measure the absorbance of that paracetamol solution, and at lambda 2 it will be, that absorbance will be used full for calculation of AY2. So from absorbance of X we will get AX1 and absorbance at lambda 1, and at lambda 2 absorbance of Y will give us AY2 at lambda 2. Similarly, this solution you have to scan at lambda 1 also, and this solution you have to scan, you have to measure the absorbance at lambda 2 also. Means in short, X you have to measure at lambda 1 and lambda 2, and Y you have to measure at lambda 1 and lambda 2. So you will get all the absorptivity, that is AX1, AY1, AX2, AY2. Now for a sample solution you have to just take absorbance at lambda 1 and lambda 2. Now coming to the calculation part. So as I told you, x you have to measure at lambda 1 and lambda 2, and y you have to measure at lambda 1 and lambda 2. So using the absorbance you can calculate absorptivity. For example, the reading of x at lambda 1, see lambda 1 is lambda max of mefenamic acid, that is 285, lambda 2 is lambda max of paracetamol, that is 255. So mefenamic acid at lambda 1 is giving us 0.663 absorbance. So how to calculate absorptivity? So for absorptivity, the equation is A is equal to, capital A is equal to ABC, small ABC, where A is absorbance, small a is absorptivity, B is a path length which is 1, C is the concentration in gram per 100 ml. So how will you calculate the absorptivity? AX1, the reading is 0.663. So absorptivity AX1 is equal to A upon BC. So what is AX1? 0.663 upon 1, because B is 1, and C, which is 10 ppm, because we have calculated absorptivity from standard solution of mefenamic acid. So 10 ppm you have to convert into gram per 100 ml. So 10 ppm is equal to 0.001 gram per 100 ml. This is very important. So absorptivity will be 663. So similarly, all the absorptivity you have to calculate, that is AX1, AX2 for mefenamic acid, that is X, and paracetamol Y, AY1, AY2 at both the wavelengths. And sample you have to take as I told you that you have to just take absorbance of sample at lambda 1 and lambda 2, that will be your A1 and A2 respectively. Now if you place the values into this equation, you will get the concentration of X and concentration of Y. But very important, the value you will get in gram per 100 ml, because absorptivity, for calculation of absorptivity, the concentration was taken in gram per 100 ml. So you will not get in ppm directly, you will get in gram per 100 ml, that you have to convert again into ppm. So that comes to Cx is equal to 6.769 and Cy is equal to 4.78 ppm. Now how to calculate percentage weight by weight? So our sample solution, as we can see here, was containing 10 ppm of mefenamic acid and 6.5 ppm of paracetamol. So these are our theoretical value which we have prepared. So these values are 100%. So mefenamic acid is our X. So 10 ppm is 100%. So 6.769 ppm is how much percent? So that comes around 67.69%. Similarly, for paracetamol, which is our Y, the theoretical value was 6.5 ppm. So 6.5 ppm is 100%. So practically we got the value 4.78 ppm. So how much percent? So that is 73.53%. So how will you report the result? The given tablet sample contains 67.69% of mefenamic acid and 73.53% of paracetamol. So this is all about estimation of paracetamol and mefenamic acid in given tablet using simultaneous equation method. I thank you all for patiently listening and have a good day.